Hello everyone, welcome back to another video. In this video I'm going to discuss the solutions of equation which do not appear as a quadratic equation. In the previous lecture I solved various type of quadratic equation, but here we will see some equation that are not in the quadratic form, so we will reduce that equation into the quadratic equation. So solutions of equation reducible to quadratic form. Suppose we are given equations in the form of ax4 plus bx square plus c is equal to 0. So this equation is not a quadratic equation, and here we will have various type of equation like this. So we will reduce that equation into a quadratic form. So what will we do? We will do this by substitution. Suppose if we substitute y is equal to x square, then y square will become x4. So if we substitute, the value of x square is equal to y square is equal to y, and y square is equal to x into 4. So we will get quadratic equation in case of y. So we will solve that quadratic equations for y. So if we solve, then we will get the original solutions by reputting the value of x. Let me do some example of equation like this. Here from exercise 1.2 we are given question number 1, x power 4 minus 5x squared plus 4 is equal to 0. So this equation x power 4 minus 5x squared plus 4 is not a quadratic equation, because here the power of x is 4. So we will change this equation into quadratic equation by substitution. So put y is equal to x square, then y square will become x power 4. So we will substitute the value of x4 into x square here. It's equation 1. So if we substitute, so we get y square minus 5y plus 4 is equal to 0. Now we will solve this equation, this quadratic equation for y, and then we will reput the value of y to get the original solution, to get the solution of x. So now we will split minus 5 into 2 terms, like if we add minus y minus 4y, we get minus 4y, we get minus 5y, and if we multiply these two terms, so we get 4y square. So we will write here minus 4y minus y plus 4 is equal to 0. Then we group the first two term and the second two terms. So from here we get y is a common, y is a vector, so we get y minus 4, and here we take minus 1, so we get y minus 4 is equal to 0. Now we will write y minus 4 and y minus 1 is equal to 0. Now by zero vector property we put y minus 4 is equal to 0, so y is equal to 4, and same as y minus 1 is equal to 0, so y is equal to 1. Now we will replace or resubstitute the value of y. We put here y is equal to x squared, so we put y is equal to x squared. So if we put x squared is equal to 4, now taking square root both sides, we get x is equal to plus minus 2, and same for x squared is equal to 1. If we take square root both sides, we get x is equal to plus minus 1. So the solution set will be is plus minus 1 and plus minus 2. So the solution set for the given equation, which we change into quadratic equation by substituting the y is equal to x square and y square is equal to x4, and then we got a quadratic equation in the form of y. So then we solve the quadratic equation for y, and after that we get solution for y, and we resubstitute again the value y is equal to x square, so we get the original solution for x, and this is the required solution for this question. Now the second type of equations of the form of a into p of x plus b divided by p of x is equal to 0 is equal to c. This equation is a form of equation which do not appear to be quadratic, but we can be reduce this equation into quadratic equation. So if we multiply both sides p of x, we get p into x square, p square x, right? And here we get b, because p into px cancel out with each other, and here we get c into p of x, right? So we can shift c into p of x into the left side, so we get a into p of x square minus c into p of x plus b is equal to 0. Now here if we substitute y is equal to p of x, so we get a into y square minus c into y plus b is equal to 0. So this is the quadratic equation. We reduce the given equation which is not in quadratic form, so we reduce this equation into quadratic equations, and now we can solve this kind of equation. We can solve equations in this type. If we are given in this type of equation, we can reduce it into a quadratic equation, and then the quadratic equation we can easily solve because we already discussed in the previous lecture. So let's take an example of the equation which is not in quadratic. So we will change this equation into, we will reduce this equation into quadratic, and then we will solve for x. So we are given x minus 4 or x is equal to 2 multiply, if we multiply x both sides, so we get x square minus 4 is equal to 2x, because if we put x here and same as here, so this become x square, and if you multiply here, this x cancel out, so we just get 4 here. Now we will shift 2x into left side, we get 2x minus x square minus 2x minus 4 is equal to 0. Now this is the quadratic equation, so we will solve using completing the square method here. So if we add 4 both sides, so we get 2x minus 4 plus 4 is equal to 4. We add 4 both sides, so we get x square minus 2x, 2 cancel out, we get 4. Now if we expand this formula, so we get 2x into 2 minus 2 into x is equal to 2 into 2, right? So we will add 1 both sides, so we get x square minus 2 into x into 1. We will add 1 here, and same as 4 plus 1 is a 4, 2 into 2, 2 power 2 is 4, so 4 plus 1, so we get x minus 1 whole square is equal to 5. So taking square root both sides, we get x minus 1 is equal to plus minus 5. So if we take x minus 1 is equal to 5 under root 5, so we get x is equal to 1 plus under root 5, and if we take x minus 1 is equal to minus under root 5, so we get x is equal to 1 minus under root 5. So the solution set will be So the solution set will be 1 plus under root 5 and 1 minus under root 5. So this is the solution set.